An experiment is any occurrence where the outcome is uncertain. For example, rolling a fair die. We don't know what the result is until we see it. Or flipping a coin, or drawing a card out of a deck. These are all experiments. The set of all possible outcomes for an experiment is the sample space. For example, rolling a die, a six-sided die, the possible outcomes are 1, 2, 3, 4, 5, and 6. That is the sample space for rolling a die. An event is some subset of the sample space. For example, rolling a number less than 3. That is an event. The probability of an event is a measure of the chance or likelihood of it occurring. Probability is a number between 0 and 1. A probability of 1 means that the event is certain to occur. A probability of 0 means that the event will never occur. The way we calculate the probability of an event is we take the number of ways that that event can occur and divide by the number of possible outcomes. In example 3, we are rolling a fair die. Assuming we're looking at a regular six-sided die, we want to find the probability of each event. So probability that we roll a 5. We want to take the possible ways that can happen. There's only one way to roll a 5. Divided by the number of possible outcomes of rolling a die. The total number of outcomes for rolling a die are 6 outcomes, because you could get 1 or 2 or 3 or 4 or 5 or 6. Part B, we want to find the probability of rolling a number less than 5. The number of ways you can get a number that is less than 5. You could have 1, 2, 3, or 4. Those are all numbers that are less than 5. So that's the numerator, that is 4. Divided by the total number of outcomes for rolling a die. Again, there are 6 total outcomes, 1 through 6. Since we have a fraction, we do want to reduce that. We'll get 2/3. So the probability of rolling a number less than 5 is 2/3. What about the probability of rolling a 9? Assuming we're looking at a regular six-sided die, that's not possible. So the probability here is simply 0. What about the probability of rolling a number less than 7? The numbers that are less than 7 are 1, 2, 3, 4, 5, and 6. We have 6 divided by the total number of outcomes, 6. We get 1. Right? That is certain. That is going to happen. If you roll a regular six-sided die, it will be a number that is less than 7. In part B, we have a bag of marbles that contains 7 red, 11 yellow, 3 green, and 5 blue. You draw 1 marble from the bag. We are assuming that this is at random. Find the probability of these events. Part A yellow marble is chosen. Notice that there are 11 yellow marbles. So there's 11 different ways to choose a yellow marble. Now we have to divide by the total number of possible outcomes. So we need to know the total number of marbles. 7 plus 11 is 18, plus 3 is 21, plus 5 is 26. So let's make a note, 26 total. So we'll divide 11 by 26. Again, 11 ways to get yellow out of 26 total possible outcomes. Part B, what about choosing a black marble? Notice that there are no black marbles, so there are 0 ways to get black divided by 26, or simply 0, because it's impossible. Part C, a marble that is not green is chosen. Not green. So we want to count the number of marbles that are not green. 7 plus 11 is 18. We don't want green. 18 plus 5 is 23. So there's 23 ways to get a marble that is not green divided by a total number of 26 possible outcomes. And part D, we want to choose red or blue. Red, there's 7 of those, and 5 blue. 7 plus 5 will give us 12. 12 ways to get red or blue, divided by the total number of possible outcomes, 26. And this one will reduce. We'll get 6 divided by 13. In example 5, you're at a cookout and there is a cooler containing drinks. There are 24 Diet Cokes, 12 Dr. Peppers, 5 Sprites, and 8 bottles of water. You close your eyes and reach in and grab a drink. Find the probability of each event. We are assuming that we are choosing at random with our eyes closed. Part A, you want to choose a drink other than Diet Coke. So probability of getting a drink that is not Diet Coke. So let's count up the number of drinks that are not Diet Coke. 12 plus 5 is 17, plus 8 is 25. We have 25 that are not Diet Coke. But now we have to add up the total number of drinks that we have to choose from. 24 plus 12 is 36, plus 5 is 41, plus 8 is 49. So the probability of getting a drink that is not Diet Coke, 25 divided by 49. And in part B, Dr. Pepper, my favorite. What is the probability of choosing a Dr. Pepper? Well, there are 12 Dr. Peppers divided by a total of 49 possible outcomes. So the probability of getting Dr. Pepper, if we choose at random, is 12 divided by 49.